I wanted to talk about transformations of functions. This is the parent function of y equals x squared. It makes a nice parabola. You have y equals the absolute value of x. It makes a sharp V at 45-degree angles. And you have y equals square root of x. It makes a shape like this. If I add something on the outside of each of these, like plus 3, now we get this red graph that is 3 higher than the black one. Shifted the whole thing up 3. And if we do a minus 1, you'll notice the red is 1 below the black. Plus 3 goes up 3, minus 1 goes down 1. And it does the same thing on all 3 of them. If I put a multiplier in front of these, like 2, it makes it twice as tall. So this is twice as tall. The height here is doubled. The height here is doubled. The height here is doubled. And the height here is doubled. And if we make it 1/2, it's half as tall. You can see that the red one is half the height of the black one. If we do a plus or minus inside the function with the x, this enables us to move left or right. So a minus 3 goes 3 to the right, and a plus 3, you can see the red is 3 to the left. So it feels counterintuitive. A plus 3 moves to the left, and a minus 3 moves to the right. But that's how these work. We can also bring back the plus 3 on the outside, and it combines the two. So this is going 3 to the left, 3 up, 3 to the left, 3 up, 3 to the left, 3 up. And we can also combine the multiplier as well. If we put a multiplier in front here, it's now going to be steeper. So you can see without the 3, it's the same width, the same shape. But once we put the 3 in there, it's now taller. Same thing here. Without the 3, it's this wide. And then with the 3, it's now steeper. And same thing here. It's the same shape. Once we multiply by 3, it's steeper. Another cool thing, you can multiply by a negative number. That's going to reflect it over the x-axis. Perfect mirrors over the x-axis. Here we can do stuff inside with the x like a minus 2. And so now it's reflected over the axis and it's moved 2 to the right. Put a number on the outside like minus 1. That would drop them all down by 1. So this is reflected over the axis, 2 to the right and 1 down. Another thing we can do is put a multiplier inside with the x. This 2 on the inside makes it half as wide. Same thing here, half as wide. Same thing here, half as wide. It's clear here that it's not twice as tall. So half as wide is not the same thing as twice as tall. It might look like it on these two, but on this one, this is clearly not twice as tall, but it is half as wide. The distance we go from here is half as the distance we go from here to here. So the x values are halved for all points. And then if we put a 1/2 on the inside with the x, it's now twice as wide. Double this to get to here. Multiplying by 2 is 1/2, and multiplying by 1/2 is like making it twice as wide. They're counterintuitive. It's the opposite of what you would expect. Why is x getting special treatment, but y is doing what's logical? The trick is this -3 is on the same side as the x. That's why it's opposite. This +3 is on the opposite side of the equal sign. So if we subtract 3 from both sides, we now have the 3 on the left-hand side with the y. Now look what's happening. Y minus 3 is going up. That's counterintuitive. Minus feels like it should go down. So whenever it's on the same side as the variable, it does the opposite of what you expect. But if it's on the opposite side of the variable, it does exactly what you would expect.